Welcome to the Explainer. Today, we're going to demystify async IO, a really powerful part of Python's standard library. It promises to make your code way faster and more efficient, especially when you're dealing with things like networks and files. So let's dive in and see how it all works. Okay, so to really wrap our heads around what asyncio is all about, we have to start with a pretty fundamental question that, every programmer runs into. What if your code didn't have to just sit around and wait? And the answer to that question? Well, it lies in this powerful concept called concurrency. It's basically the art of escaping that waiting game, and it is the absolute core idea that makes async IO even possible. So what is concurrent code, really? Well, here's a great way to think about it. Imagine a chess master playing like 10 games at once. They don't finish one entire game before starting the next one, right? No way. They make a move on one board, then immediately switch to the next, and then the next. Your program can do the exact same thing, juggling multiple tasks and making a little bit of progress on all of them, instead of getting stuck waiting for just one to finish. This is an absolute game changer for what we call IO-bound tasks. And think about it. Anytime your code is just waiting for a web page to download or for a database to get back to you, or even for a file to load from your disk, your program is just sitting there, totally idle. Async IO is designed specifically to reclaim all that wasted time and put it to some really good use.
All right, so that's the theory. But how does Python actually put this idea into practice? Let's take a look at the basic syntax with a simple hello world example for asyncio.
Now, at first glance, this looks like pretty normal Python, but you'll notice those two new keywords right there on the screen, async_def and await. See, async_def defines a special kind of function. It's called a coroutine. And then when we get to await async.sleep1, we're basically telling our program, hey, pause right here for 1 second, but don't block everything else. If there's other work to be done, go do it. Then, after that second is up, it comes right back and prints, woo, world. Let's really break that syntax down, because these three pieces are the magic behind it all. First up, you have async_def. That declares a coroutine, which is just a fancy word for a function that knows how to be paused and resumed. Second, you have await. That's the keyword that actually does the pausing. It hands control back to a central coordinator, basically saying, hey, I'm waiting now, so let something else run. And finally, async.run. That is the central coordinator. We often call it the event loop. It's like the conductor of an orchestra, making sure all the different tasks get their turn.
Now, all of this builds into a really practical toolkit. And the good news is, for most of your day-to-day work, you don't need to get lost in all the low-level details. Asyncio gives you this fantastic set of high-level APIs to work with.
So what's actually in this toolkit? Well, Async IO gives you tools for running multiple coroutines at the same time, for doing network stuff like making web requests, and even for controlling other programs on your computer. It also comes with things like queues, which let you safely pass data between tasks, and synchronization tools to make sure your concurrent code doesn't trip over itself. This is really the core set of features you're going to use to build powerful async applications. But Async IO isn't just for application developers. It's also got this more powerful, lower-level layer that's designed for the people who build the frameworks and libraries that the rest of us rely on every day. And this slide really highlights the two different worlds of asyncio. On one side, you have us, the application developers, using those nice high-level APIs to build our apps. But on the other side, you have the framework developers. They're using the low-level APIs to do the heavy lifting, like managing the event loop itself, implementing network protocols from scratch, and even connecting to older callback-style code. Okay, so we've seen the what and the how, but let's just take a step back for a second and look at the big picture. Why is this so incredibly important for the whole Python ecosystem? If there's just one thing you remember from this entire explainer, what should it be? The most crucial point is this. Asynchrony isn't just another library. It's the foundational engine for a huge part of the entire modern Python world. We're talking high-performance web servers, super efficient database drivers, complex distributed systems. So many of today's most critical Python tools are built on the very concurrent foundation that asynchrony provides. So, by understanding asyncio, you're not just learning a new tool, you're learning the mechanics behind the whole next generation of Python software. And with that, we'll leave you with this question. Now that you know the fundamentals, what are you going to build